So the session we have now is about simulating the wireless TSN bridge with our simulator. And for that, we developed a extension for the INET framework, which we worked earlier with, to enable the simulation of these networks with the characteristic network delay. And what the goal of this tutorial now is first to set up a network with this characteristic delay. And after that, we will talk a bit about scheduling in these networks. So the first task should be quite simple. Let me quickly jump into the tutorial here. And you are given a network which has two switches. And the first task is about replacing this switch here, the DATCOM TSN switch with the DATCOM node. And you should have all important information in the INI file. There's a description of the task as well with some links to the documentation. But before we start that, you should do a small change and right-click on the deterministic 6G project and click on Show in Terminal. And then just type a git pull because I had to do a small change on this task. And after that, you should be ready to go, and I will give you 5 to 8 minutes, and then we will discuss the first task. And if any questions online occur, I think I can help online, and if there are any questions in presence, Simon and Frank are also there to support. And if you are fast, you're of course allowed to already continue with task 2 afterwards.
Yeah, maybe it's a good idea to first present all the tasks, and then because then people can already start working on the previous tasks. And
yes. All the task descriptions are also in the Omnet INI file. They are even more detailed there. So I think if someone is faster than the slides are, then you can just read the next task description in the INI file.
Thank you. I do the rest.
maybe for everyone online who's participating, if you're done with the first task, you can maybe raise your hand so I kind of have a small overview on how fast you're going with the tasks. Simon or Frank, can you maybe tell me how it's going in the live room?
Exactly. I think in the room we have at least one who is actively trying to do it.
All right. I think some people here online, they are mostly observing and waiting for more detailed descriptions. So I think
that's also
I
my
will,
feeling. So maybe we do it this. We also run a little bit short in time because my Hinstall is
yes.
also 30 minutes and starts at 3. This time I'm really looking for that. And therefore I would say, please maybe show the how you do the tasks and
Yes, okay.
then do it for all the tasks, because then everybody can repeat it if he or she likes to do that.
That sounds like a good idea. So for the first task, let's open the solution network. It's basically replacing the TSN switch by our DATCOM node and then putting the right connections here. And we saw a figure earlier about a DATCOM node, I think, with the device-side TSN translators and the network-side TSN translator. And there should be on this link with the documentation, you can see the structure of the DATCOM node here and also a description of the gates. And if we now run this simulation here, which takes a second, we can see our DATCOM node here with one device-side TSN translator per talker and the network-side TSN translator on the network side. And if we now execute the simulation, we can see that the talker sends a frame to the DATCOM node, and this is going through. And if we now explore, I should run the simulation to the end, otherwise there are no result files. If I now quickly run the simulation until the end, then we should be able to create a result file where we can browse the data for the mean bit lifetime per packet, which is basically the end-to-end delay. And we can explore the end-to-end delay. And right now, we can see that the end-to-end delay in our simulator is constant. And that's because we don't have any delay configured yet, which is the exercise of task 2 to configure the delay. But I think most of the people are watching, so I will go through that directly, I think, also because of the time now. So if we go back to our simulator, to the ini file, here is this the right? Yes. We can go to task 2, where the task was to set up the delays. And we provide in another repository already some measured delays, also from KTH, from the measurements Gurho just showed in the last presentation, some delay files. For example, this histogram here, which I also have a figure of, that looks like this. And we can load it into our simulator by simply providing the path of the histogram file and then setting the uplink delay of the first TSN translator to this uplink delay in our histogram container here. And the second part of the task was to configure the second talker to have a delay with a normal distribution, and that's something Omnet++ already provides. So we can simply specify the uplink delay of the second talker to have a normal distribution with a mean delay of 2.5 milliseconds and a standard deviation of 500 microseconds. And if we now simulate this configuration again and choose task 2 here, and then wait a few seconds until it's done. It's always a bit slow in the VM, so we need to wait a short time. Then we can go back to our ANF file and now look at the mean bit packet lifetime of task 2. And let's first look at the histogram of it. So we open the first talker and take a look at the histogram, and then we can compare it to our uplink histogram, which we provided as an input. And of course, because it's quite a short simulation, the resolution is not as good as in the right figure, but we can see it follows the same structure with the mean delay approximately at 5.6 milliseconds in both figures. And also we can do the same for our second talker, which we defined with a normal distribution with the mean of 2.5 milliseconds, and we can also see the outgoing, the outcoming histogram here. So that's how we configure the delays in our simulator. And for the next part about the scheduling, I would maybe give the word to Simon, if that's possible. Frank?
Okay, yeah. So so we have seen that we might skip that part, and we directly go to the time sync part now. Yeah, since we also want to see what's new in time synchronization in 5G.
Then maybe if it's possible, we would have 2 more minutes because we had a question about that earlier, so I can quickly show the effect. Just like 1 small second. So if you want to explore it in more detail, the code is on GitHub. I can send a link to that later. But if we now execute this network with a wired schedule, which is the part of task 3A, let me quickly execute that. I also don't need to run it to the end. That should be, oops, that's wrong, should be fine enough. Sorry, that was the wrong button. Then we can see in a few seconds that the schedule completely breaks with delay, and that's what we might also use packet delay compensation for. Give me 2 more seconds so I can show you that. Task 3. That is great, because Omnet just crashed when I wanted to show that. That sometimes happens if you work with Omnet. There are random crashes, but you know, that's what happens in a live demo. So let's go back to the ANF file and view the mean bit lifetime per packet of task 3A. And here we can now see that the delay is way greater than what we defined, and that's because the schedule, so we have 5 milliseconds here, and here we are at over 50 milliseconds. And if I can change the x-axis to a bit, we can see that in the first 2 iterations, or the first 2 frames, they arrive in time, and after that, because the packet arrives after our gate control is opening, it's queued until the next cycle, and the schedule is broken for the whole rest of the operation of the network. And that's something which you can fix with schedules until a certain point, but with a really big delay distribution, it's quite impossible to isolate the frames. So you need packet delay compensation to still have an efficient network with a lot of streams and being able to isolate them, which we can see in this figure here. That's the only thing I want to show to maybe answer the question from earlier a little bit more. So maybe I don't know exactly who asked the question earlier, but does that answer the question in a bit more detail?
Okay, looks good.